Hello students, in this video we have 10th illustration of chapter 5. The question is, a solenoid has core of a material with relative permeability 400. The winding of the solenoid are insulated from the core and carry a current of 2 ampere. If the number of turns is 1000 per meter, calculate H M. What is H? Magnetic intensity. M is intensity of magnetization. B, that is magnetic induction, and magnetizing current. We'll see what is magnetizing current. First, let us understand situation. The situation is, we have a solenoid, and to study magnetic property of some material, the material is placed inside the solenoid, and then current is allowed to pass through it. So suppose this is the material which is to be studied, and to study its magnetic property you allow current to pass through the winding of solenoid. And for this situation we are told that relative permeability, that is mu r, is 400. Okay, which other data we are given? We are told that from winding of solenoid we have 2 ampere current passing. So it is current due to free charge, IF I would call it, and 1000 turns per meter, that is small n. Small n is 1000 turns per meter, so 1 upon meter. And then you are asked to find out magnetic intensity, that is H, intensity of magnetization M, magnetic induction, that is B, and magnetizing current IM. So we'll start with H. If you remember the formula, H is NIF. What is N? 1000 here. What is IF? 2 ampere. Okay, so you should be able to calculate H. Once you have H calculated, uh, instead of going for M, I think we can calculate B first. So B is nothing but mu H. Now what is mu? Mu is permeability of the material. We are not given that. Instead, we are given relative permeability. So I would change this formula slightly. B is equal to mu R mu 0 H. Why? Because we know that mu R, relative permeability, is mu by mu 0. Okay, so now in this expression we have everything except B known. So using equation 1 we can find out H, using equation 2 we can find out B, and then M should be easy to calculate. What is M? How to find out M? So we have one formula relating B, H and M. The formula is B by mu 0 is H plus M. So with this formula, let us call it equation 3. We should be able to find out M as well. Now, what is magnetizing current? Magnetizing current is the current which we will need to pass through the winding of solenoid if we don't have the core material with this 400 relative permeability. Suppose if I remove this material, and yet if I want same value of magnetization, how much current I need to pass through the winding? So for that, uh, what I have to use is B is equal to mu 0 H. Okay, so I would say it is B is equal to mu 0 N, and now I will not take simply IF, I will take IF plus IM, because now I want the B value which I have calculated in equation 2. I want this much B value. Okay, but I don't have this core material, and then what I need is I'll need to pass extra current, and that is IM. So from equation 2 you will get B value. Okay, from equation 2 you will get B value, and rest of the things are available. N is known, IF is known. We should be able to calculate IM. Okay, So substitute values and equation 4 will give you magnetizing current. Thank you.